Let's talk about a secret weapon that programmers use every single day. It's a surprisingly simple, but trust me, an incredibly powerful tool called the stack. Understanding this is going to change the way you see the software you use all the time.
So I want to start with a bit of a puzzle for you. What could your browser's back button, that undo command that we all rely on, and a regular old stack of plates possibly have in common? I know, it sounds like a weird riddle, but the answer actually gets to the very heart of a huge concept in computer science.
And believe it or not, the key to that whole riddle lies right here, with something you see every day. We're going to use a simple stack of plates to figure out exactly how a digital stack works.
So, what is a stack really? Well, at its core, it's just a collection of items that follows one very, very specific rule. Last in, first out, or as you'll hear it called, LIFO. That single principle, it's the key to everything.
Just think about it for a second. When you're putting away clean plates from the dishwasher, you put the last one right on top, right? And when you need a plate for dinner, which one do you grab? The one on top, the one you just put there. The last one in is always the first one out. That right there is LIFO in a nutshell.
Okay, so if we can only ever work with the very top of the stack, how do we actually, do anything with it? Well, it all comes down to three super simple actions: push, pop, and peek.
There are really only three main things you can do with a stack. First up is push. This is just the fancy word for adding a new item. In our plate analogy, you're literally just pushing a new plate onto the top of the stack. Simple as that.
Next, you've got the opposite of push, and it's called pop. When you pop the stack, you're just removing that top item. You're taking that plate off the top to go use it.
And finally, there's peek. This one lets you just look at the top item without actually taking it off. It's like checking the pattern on that top plate before you decide if you want it. So you push to add, pop to remove, and peek to look. That's it.
Okay, so the rules are dead simple. Last in, first out. And all you can do is push, pop, and peek. But what's the big deal? Why is this so special? Well, the answer comes down to one thing: pure, unbelievable speed.
Now, under the hood, a stack can be built a couple of different ways, usually with something called an array or a linked list. But honestly, you don't need to get lost in the weeds here. The crucial point is that both of these methods are designed for one thing: making any interaction with the top of that stack ridiculously efficient.
In programming, we have this concept called time complexity, which is just a fancy way of asking, how fast is this thing going to run? For stacks, all three of those main operations, push, pop, and peek, run in what's known as constant time. And here's the magic part. That means they take the exact same tiny amount of time to finish, whether your stack has 10 items or 10 times million. It never ever slows down.
And this chart really puts that into perspective. On the grand scale of performance, constant time isn't just good. It's way, way up there in the excellent category. It's pretty much the gold standard for speed. And it's why stacks are trusted with so many critical jobs.
So let's circle all the way back to our original question. Now that we know what a stack is and why it's so lightning fast, where do we actually see these things out in the wild? Get ready for the aha moment.
The answer is they are absolutely everywhere. I mean it. Every time a program runs a piece of code, it gets pushed onto something called the call stack. When you hit undo, you're literally just popping the last action you took off a stack of commands. Your browser's back button? You guessed it, it's just popping the previous web page off a stack of your history. It's this beautiful, elegant solution hiding in plain sight for a huge number of problems.
So why does any of this matter? Why have we spent all this time talking about digital plates? Let's bring it all home and see what the big takeaway is. When you really boil it down, you take that one simple principle, last in, first out, and you combine it with a few essential actions like push and pop, and you power the whole thing with that blazing fast, constant time speed. You don't just get a clever tool. You get a fundamental building block of pretty much all the software we rely on every single day. And that kind of leaves us with a final thought, doesn't it? The stack is so powerful precisely because it's so simple. It really makes you wonder what other seemingly basic ideas and technology are out there quietly having a massive, outsized impact on the world all around us. It's definitely something to think about. Thanks for joining me.